Hello everyone, welcome to the class. This is Mohan Raj from Genesis Training, and I'll be your trainer who will be teaching quant and reasoning classes through the videos. Okay, so we are going to see a very interesting topic. Before that, let me introduce myself. As I said, I'm Mohan Raj and I have 8 years of experience in training students at various levels, starting from 11th, 12th standard mathematics to the students who are graduating, who are trying to go for a placement, and for the entrance exams like GRE, GMAT, CAT, SAT. So I have teaching maths for all the students from the past 8 years. Okay, so let us go with the very basic topic today, that is speed maths. What is this speed maths is all about? Let's see what is speed maths is all about. This is about faster calculations. Okay, the name itself says speed maths. As we are not allowed to use calculator in our aptitude exams, we need to learn new methods, unconventional methods, which are not used by us regularly. Okay, the reason is we need to get the answer within a minute, and we don't have to write every step. That's what we were doing in a conventional method, right? So every calculation we used to write down, or we use a calculator. So all this can be avoided. So let's see how to do with this multiplication by base method. So this is one of the first video in speed maths. So you'll be having series of such videos in the coming videos. Okay, let's see what is this all about, base method. And I'll be starting with the example directly. There is an example here, 105 into 103. I need to multiply these two numbers. Let us see what is the conventional method. In our conventional method, we multiply digit by digit, right? So 3 5s are 5, 3 0s are 0, 3 1s are 3. And again we write this on the next position, and again we write this 1 times 105 is 105, and then we are going to add this. This is going to take a lot of steps as well as time, and as I told you, we will not get marks for steps, so we have to avoid all this. Okay, so what is a better method? I call this as a base method because we have to consider a number as a base which is near to both of them, and it's an easy number. So what is that number? 100. So 100 is near to 105 as well as 103. So I am going to take 100 as a base. Okay. So now my number 105 and 103 both are more than base. 105 is more than base by 5. So I write plus 5. 103 is more than base by 3. So I write plus 3. Next step is you need to add this. In any one direction you can add. Both are going to give you the same result, which is 108. And the next step is you have to multiply by the base we have considered, that is 100. So what we get is 108 into 100, which is 10,800. And coming to the final step, we have to multiply the deviations. I call it as a deviation from the base. Plus 5 into plus 3 is plus 15. That means I'm going to add that to the final result. So this is going to give you the answer. If you have checked here, this is the same answer we are getting here in this method as well. 10,815. Hope this is clear. Let us see some more examples and how the second example is different from the first one. Let's see. Yes, here we have 98 and 96. Both are near to a number which is 100. Again, base is 100 for us in this question also. Okay, but here both the numbers are less than 100. This is 2 less than 100. This is 4 less than 100. Okay, but now changing our steps. It's all same. So we add this in any one direction. We get the result as 94 into 100 is 9400. And finally, we have to multiply this minus 2 and minus 4. We get plus 8. The total value is going to be 9408. Let's go to next one. And this is again different from the previous example. How it is different, you can only check. One number is more than 100, one number is less than 100. Again, both are near to 100 only. So I can take base as 100 again. So it is plus 3. This is minus 2. Again, if we can add this in any one direction, we get 101 only. Right? So 101 into 100 is 10,100. Then finally we get plus 3 into minus 2, which is minus 6. I am getting the answer. That is, when you remove 6 from 100, we get 94. When you remove 6 from 10,100, we get 10,094. This is your answer. So coming to the next number, 204 into 195. And what is this? How is this different from the previous examples? Is base itself is different here. This number is near to 200, so I'll take 200 as a base. This is 4 more than 200, it is 5 less than 200. And when we add in any one direction, either 204 minus 5 or 195 plus 4, we get 199. Now I need to multiply by 200. So even though it is easy to multiply, 199 into 2 is 398. I can also see in a different way. I can see this as 200 itself. 200 into 200 is 200 into 2 is 400, but actually it is not 200. It is 1 less than 200. When you double it, actually it is 2 less than 400. So the value will be anyway 398 followed by 2 zeros. So I'm just giving you some other tactics to get the answer faster. Okay. So you can also find out your own tactics, but you should get the right answer. And plus 4 into minus 5 is actually minus 20. I need to remove 20 from 800, which is going to be 39,780. This is your final answer. You need to increase the speed by avoiding the writing all these steps. We have another number now, 408 into 396. So this 396 is less than 400. As our base is 400 now, I'm going to take minus 4. It is less than 400 by 4. And I'm going to write plus 8. Okay. So now when you add in both the direction, we get 404 into 400. Again, I can imagine this as 400 to 4 is 1600. It's all in my mind. I'm not going to write this when I'm doing it. I'm just explaining you all this. 4 into 4 is 16. So the sum is going to be 16 followed by 2 zeros. Further, we have to multiply plus 8 into minus 4 is actually minus 32. Now we're going to remove 32 from 600. So it's going to be 1,61,568. This will be your answer. How fast you can do it is all about your practice. You do more practice, you get the answer faster, and you will also avoid all this writing. How to do that faster? See, this can be done in my mind. I don't have to write all this. I can say plus 8 in my mind and minus 4. I can only add in only one direction. I get 404 into 104, which is 1616, followed by 2 zeros, and then finally minus 32. Only this much I'm going to write when I am doing it. I also expect you to try this so that you get the answer faster, and this method proves to be a worthy method to use this in the calculations. This is a number 505 into 495. Can you guess what is the base? The base is now 500. Yes, you're right. It is 500. So from 500 it is plus 5 and it is minus 5. When you subtract or add in any one direction, you get 500 into our base 500, which is actually 25 followed by 4 zeros. Then finally minus 5 into plus 5 is minus 25. We're going to remove 25 from 2,50,000, which is going to be 2,49,975. But have you observed this in any other way? It is not always a base method you have to use. You can also see this as 500 plus 5 into 500 minus 5. What is this? What format it is? It is of the form a plus b into a minus b. And we are all aware of this expansion. We end up with a square minus b square. So this can also be seen as 500 square minus 25, which will give you the same answer, 2,49,975. Let's go to next example. 796 into 805. So now you can only tell the base is actually 800. So it is minus 4 here plus 5 here. When I add this, I get 801 into 800. Again, multiplying is easy here. 8 into 800 is 6400. 8 into 1 is one more 8, which is going to be 6408, followed by 2 zeros. Then minus 20, minus 4 into plus 5 is minus 20. My answer is 640780. Right? Let's go to next example. Let us try some 2-digit numbers. It's not always 3-digit. If the method is right, it has to be right everywhere. the base method should work everywhere. Then only I can take it as a method for our calculations. We want to restrict ourselves to the methods which are not applicable everywhere. So this method should be applicable everywhere. Then only we will learn it. Let's see the example. 37 into 41. So what can be the base? You can assume the base as 30 or 40. You can also take 35 as a base. I don't have any restriction. You can even take 37 as a base. Which is easy for you, you can take it. I'll take 40 as a base. It is minus 3 plus 1. I end up with 38 into 40. So I can also do that in mind again. 4 into 30, 120. 4 into 8, 32. It will be 152 followed by a 0. And then minus 3 into plus 1 is minus 3. Our answer will be 1517. Let's go to next one. 27 into 26. What is a base you're going to consider? You can take a base as a 30 or 20, but I'm going to take it as 25. Let's see, if 25 is a base, how will you get this answer? It is more than 25 by plus 1. It is more than 25 by plus 2. When you add this, we get 28 into 25, and multiplying by 25 is also easy. You can imagine this as 25 into 25, 625. One more 3 is left. 3 into 25 is 75, which is going to be giving you 700. So I'm going to write this as 700, and then plus 2 into plus 1 is plus 2. When you add this, you get 702. This is your answer. Let's see one more example. 85 into 91. So here 90 is a base. I call it as base now. So this is minus 5 plus 1. I end up with 86 into 90. Again 9 into 80 is 720. Everything is in mind. This cannot, this I won't write. I'm writing it only for you to understand. You should not write it. That will take time. You should do it in the mind. Followed by a 0. Then plus 1 into minus 5 is minus 5. The answer is 7735. Hope this method is clear to you. But remember guys, this method can be applicable only if the numbers are nearby. Only the base can be established easily. You can apply this everywhere, but it won't be easy. If I give a number which is very far from each other, then also we can apply base method, but that will not be a better method for us. So what are we going to do that we will see in the next video, what to do if the base method cannot be applied. So now this is your section where you are going to practice this, and you can also practice by taking your own questions, your own numbers, random numbers. You can verify the answer by using calculator later so that you can get the calculations faster. Okay, so let me see you again in the next video, which is multiplication by Vedic mathematics. Thank you.